We are NeuraCrop AI, and we're excited to share the technology dedicated to getting powerful agricultural data at the fingertips of farmers. With a projected population increase of 2 billion people in the world by 2050, an estimated 70% increase in food production is required to sustain this new population. Our mission is to empower farmers to harness the power of the data around them to meet these needs. Each day, a farmer has to answer several key critical questions, such as how much water should crops receive, and are crops getting enough sunlight? The decisions they make affect crop yield, and in turn, become responsible for providing enough food to sustain the population. However, one major issue with this is their lack of information. Farmers are not sufficiently equipped with quantitative data to make the best possible choices for their crops. With water shortages, issues in cost management, and problems in productivity, big data analytics has become a significant tool in improving farm efficiency. Sensors have been undergoing extensive updates to decrease cost and increase accuracy in order to collect massive amounts of data to then synthesize this information through monitoring systems. Constant monitoring provides enough knowledge for the network to predict key points in improving crop yield and optimizing cost and efficiency. Artificial neural networks have been quite successful with their predictions in farming contexts, including in year-round air temperature and soybean rust predictions. Increasingly accurate results were generated with artificial neural network modeling of soil water and soil physical properties. The error found in maize yield based on rainfall, soil, and other parameters was as low as 14.8%, demonstrating the immense potential of big data-dependent systems.
Although precision agriculture informed by IoT technologies has shown promising efficiency increases, many challenges still exist, notably unintuitive user experiences, a lack of a universal platform to synthesize meaningful data, low scalability to get data from different crop types within a field, and limited results from the predictive analytics of today's ANN systems. That's why we've introduced NeuraCrop monitoring system. Our product promises 3 components. 1, a basic low-cost sensor kit that comes with a few necessary sensors that feed into the system, a PINS-informed data analytics software with increased predictive accuracy and the ability to provide new indicators to plant growth and plant health, and finally, an accessible user interface that provides a universal platform to aggregate data in a meaningful way. The app also allows farmers to access their data regardless of their location. We've pinpointed our target customers and partners to the APAC region, where we've already seen visible cost and efficiency improvements from precision agriculture, a huge market penetration opportunity, and low presence of agriculture startups. We've identified governments as key partners who will help potentially subsidize our product to farmers and also provide as regulatory partners for regulatory relationships.
Our proposal uses an end-to-end 2-layer machine learning pipeline. Our first layer is comprised of a physics-informed neural network to compute intermediary variables. The key reason why physics-informed neural networks perform well here is that they transform our set of inputs alongside physical properties of the plant, such as vasculature and temperature, into robust and generalizable predictors. This enables us to use fewer data points to achieve similar results. After processing our data to compute statistically significant variables, we'll feed our final set of features into a gradient-boosted decision tree to output parameters like plant health and crop yield. We use a gradient-boosted decision tree since it is known to perform well in regression problems involving smaller data sets with unknown measurement noise.
The input values for our neural network will be from agricultural sensors and include the soil humidity, specific humidity of the air, light intensity, air and soil temperature, and crop type. The underlying physics that informs the neural network will be a series of heat flux equations and fluid potential flow equations, which dictate the amount of water, pressure differential, and velocity of fluid flow through the plant. The hidden value or hard-to-measure quantity that we derive from our physics-informed neural network will be the transpiration rate of the crops. From here, we will input the transpiration rate and chemical factors such as pH and nitrogen uptake, which are all strong indicators of plant health, into a gradient-boosted decision tree, with our second layer outputting a predictive yield score for the crops with the current input conditions. As the conditions change, the neural network will reevaluate in real time, giving farmers a powerful tool in understanding how the inputs directly correspond to the crop yield.
Our strategic plan consists of 4 different parts: an expansion plan that details that we will begin within the Australian commercial wheat farming market and expand to different crops in different regions within 5 years; a revenue stream plan, which follows a B2C model that includes an initial kit fee and annual subscription fee for our service; key partnerships with governments and philanthropic organizations; and then finally an exit strategy that details an acquisition with a company wishing to expand their technology portfolio or expand to a new region. And last but not least, below is our team that consists of individuals that have the experience and passion to execute our plan and vision to success.